I really like Anthropic's artifacts that you pop up on the side. Got to write a blog post. They're not quite there the way I want them yet, but it's really cool to be having a conversation about something that stays statically on the screen. Stateful objects of discourse is what I call them. We're both talking about this thing. It's not just one conversation, and the thing I've talked about is moved off the top somewhere. So eventually, we're going to be building more and more stuff like that.
Today we had John Berryman. He was an early engineer at GitHub Copilot. He worked on completions and chat. Now he's writing a book on prompt engineering, and he's a principal consultant at Tinkerers Labs, which is a company that I think you start yourself, right?
Yep.
And they work on everything LLM applications related. So John, welcome to the webinar.
Yeah, good to be here. Shall we just jump right into it?
Well, I got one question for you before we start.
Okay, yeah. Sure.
Okay, so I heard from anonymous sources that they told me that you should be talking about the skeletons in your closet. So I want to know more about that.
Yes, you've been talking to my former manager. And yes, I have, growing up, I had skeletons in my closet. But rather than get into the full story about how that was literally true, I'll tell you what, look up, see if you can find a Wikipedia page for my dad. And if you find it, you'll know exactly why I had skeletons in my closet. And tell me meet me on Twitter, John Berryman, JNBRYMN. So if you find it, it's kind of a race. See who you can figure it out first. And then at the end of the talk, maybe we'll come back to it.
All right, chat, you know what to do. Okay, John, you can take it from here.
All right. I'm gonna share my screen. Click. I'm gonna do entire screen just in case I need it. It's always a good source of embarrassment for myself. Live risky, right? Oh, and also do that trick. All right. Can see everything just fine? Yes, I can't hear anybody.
Yes, sir.
All right. Okay, great. Here we go. All right. Okay, so I had a quick introduction, but by way of introductions, here's how I got here. Started out in aerospace engineering and ended up being in that field long enough to basically just get the merit badge. Found out that I loved software and math. So from there, I went into technology consulting, specializing in search. And I over-specialized myself and ended up writing a book on search called Relevant Search. And finalized that career when I went to GitHub, and I worked on the next generation of search 2 generations ago. So that'd be currently the last generation of search, but it was a lot of fun working with the absolute largest index I've ever worked with. I moved from there into data science, something that I've always wanted to get closer to, my love for math. Ended up getting the fantastic, lucky opportunity to be one of the early engineers on Copilot right after the research had wrapped up. Basically, the research team, which was the super, super cool team, had said, wow, this is going to be a really neat thing. They built the basic product, and I was one of the early engineers that got to work on it as it was being productionized. At this point, why not pretend I'm a prompt engineer? So I being one of the early ones that happened to be in this field, I signed up to write a book about that. And now I've since moved on from GitHub and am currently consulting at Tinkerers Labs, everything large language models. So what is a large language model? Well, who better to ask than a large language model itself? ChatGPT. A language model is a type of artificial intelligence system that is trained to understand and generate human-like text. It learns the structure, grammar, and semantics of a language by processing vast amounts of textual data. The primary goal of a language model is to predict the probability of the next word. You know what that is? That's that goofy middle prediction button when you're typing a text message. You know, the one you never use because it's basically worthless? How on earth is that functionality taking the world by storm right now? So let's dig in. Maybe the difference is that we're talking about not just language models, but large language models. It's the same thing as the language model on your phone in form factor at least, but it's a lot more accurate, a lot larger, a lot more accurate. So let's give you a bit of a history lesson that is going to be kind of relevant to the stuff we talk about later. Circa 2014, recurrent neural networks were all the rage. Basically, you'd have a network composed of an encoder side and a decoder side. You feed one token in at a time on the encoder. It would build up this internal state. And then when you say, I'm done, it would turn it over to the decoder, where it would take that internal state and decode it recurrently and slowly just kind of shrink it away until it's had emitted tokens that matched, hopefully, what your request was. But there was a problem in that between the encoder and the decoder, this thought vector, this one piece of information they shoved across, was limited. And so these recurrent networks, even though they were cool, had a lot of trouble remembering details about large blobs of text. You could give them arbitrary long pieces of text, but at some point they just became, forgetful. So in 2014, someone came up with this attention mechanism. It wasn't even called that in the original paper. It's called soft search, but it was a way of getting around this bottleneck. It allowed the decoder side to not only look at this thought vector, but also kind of selectively attend search over the intermediate thought vectors that were part of the encoder step. So that happened to work really well. In 2017, Google published a paper, Attention is All You Need, which exploded into the world we see now. And effectively what they said is, okay, attention, literally, that mechanism is the thing that makes everything much easier. We don't have to worry about this recurrent network, neural network stuff anymore for the time being. Attention is all you need. And the results speak for themselves. This transformer architecture that was introduced has been spectacular, but it's not without its problems. Recurrent neural networks could take an arbitrary number of tokens. Transformer architectures have a finite window, and we've been pushing and pushing and pushing to get that window larger. And it's, even at 100,000 tokens, it's still small. Like your average web page often is more than 100,000 tokens. So surprisingly small, even though that number sounds big. In 2018, we're actually not to the present time yet. In 2018, the GPT was introduced, generative pre-training transformer. And the big cool idea there was, well, we don't even need the encoder anymore. We just need the decoder and just have it start decoding tokens just off on the fly. And we can actually stuff it with, some prefix tokens. It's actually the exact architecture that is the foundation for the models that are so popular today. An important aspect of this is in 2018, these models were considered pre-trained. The idea that has been just consistent for the first however many years of ML engineering is that you create, I guess this is since the 2000s, but you create some sort of architecture that you think is going to work for your project. You feed it a bunch of unlabeled data, because there's lots of that on the internet. And then once it's able to predict the unlabeled data, then as the last step, you do that was the pre-training. As the last step, you actually do a fine tuning of a final training to get it to do the very specific type task that you want. Sometimes this even involves re-architecting that model itself for that last step of training. So this was cool. It was generative pre-training. You end up with this kind of weird, flexible decoder thing. All right. In February 2019, that's where things got a little bit weird. Language models are unsupervised multitask learners with simply the same architecture as the 2018 paper, but 10 times the data, 10 times the architecture size, roughly. They introduced the results with this phrase in their blog post. Our model, called GPT-2, was simply trained to predict the next word in 40 gigabytes of internet text. Next sentence. Due to our concerns about malicious applications of the technology, we are not releasing the trained model. Like, holy cow, how do you get from the first sentence, which is like the same thing as the middle of my phone. It's like, we're just going to predict the next word in text. How do you get to, oh my gosh, you know, security concerns, the world's going to end. This thing is dangerous. Well, the interesting thing that they found out with GPT-2 is, even though it says it there, even though it was PT, even though it was just a pre-trained model, the pre-trained model was now state-of-the-art performance for tasks that were once performed by very tightly controlled, specifically trained models. So one generic model, GPT-2, could do missing word prediction, pronoun understanding, part of speech tagging, text comprehension, and as we found out, summarization, sentiment analysis, question answering. You can make up stories. Your kids can write essays for their, you know, English class without letting you know. It can do all these different things in this one pre-trained model. And so what this paper was, what that commentary was actually getting at is, if you have the power to predict the next word, and if you can do it really accurately, then you can generate misleading news articles and impersonate others and wreak all sorts of societal havoc on the internet. You can do all sorts of bad stuff. So this phrase, we know there's a missing sentence here between these two sentences. And the actual thing was, you know, our model called GPT-2 can predict words. And we figured out that now you can do all sorts of amazing stuff if you ask it. It'll just do it. It's amazing. But it'll also help you make bombs and drugs and overthrow governments. So due to our concerns about malicious applications, we're not releasing this. Okay, so that brings us up to the current day. Now we have this weird beast. On paper, all it can do is predict the next token, which doesn't seem like much. But in practice, it can do some amazing things. So for the next few minutes, about a third of the slides, I'll go through some of the techniques that have been discovered along the way. And a lot of these are roughly in the order that they were discovered, but they're still very relevant today. And we'll talk about what it is like to do prompt engineering, the tools of the trade, if you will. The first technique is called few-shot prompting. It's the first thing that they discovered for controlling these GPT models. Basically, these things are predicting the next token. So if you give it a pattern that it can, air quotes, reason about, then it wants to continue that pattern. It's just kind of the natural thing it does. So if you want, you know, as a pre-trained model, it doesn't do anything specific. But if you want it to specifically translate text, then you give it a bunch of examples of it translating text. And then you give it the actual task, the final thing that you want it to translate. And sure enough, being a good document completion engine, it'll fabricate this into existence, and it happens to be really good. So think of any pattern that you can imagine, and that's when people realize that, wow, these things can do kind of whatever. The next big breakthrough was chain of thought reasoning. Oh, great side note too. I have to make sure that we get these slides to everyone here, because see these little green links on the slides? They're all over the slides. These are all the papers that kind of made us who we are today. So it's kind of hopefully you can read over these slides later and find it useful to go see where this information actually comes from. But back to it, the second big deal was chain of thought reasoning. And basically, if you ask a model a somewhat complex question, like it takes a baker an hour to make a cake, how long does it take 3 bakers to make 3 cakes? Then you get the, you know, real quick thinking answer. It's just going to say blindly 3. That feels like a good, statistically reasonable completion, but it's wrong. It'll still take the bakers 1 hour to make the bread, presuming, of course, they're making it in parallel. The way that you get the earlier models around this, and it's still very useful, is by giving examples of it thinking more deeply. So on this little image, I can only fit one example, but you know, find like 20 really good disparate examples about high-level reasoning, talking about the answer first and then answering it. And when condition the model with these examples, then sure enough, the answer actually demonstrates this same behavior. It completes the document, but the model looks up and says, okay, well, for everything before, there has been thoughtful reasoning, and then the answer, so I'll just do the exact same thing. And it tends to be much more accurate with its results. Now, that was January 2022. A funny thing happened in May. This is probably my favorite research paper out of all this stuff. Someone found out that, enough of that few shot example stuff in this specific case of making the models think harder, then all you have to do is say, let's think step by step. And in a lot of cases, you can get rid of all those examples and it has the same behavior, which is really cool. Important for two reasons. One, much less work. You don't have to source your examples and find just the perfect examples. And two, a lot of times, and this is something we still have to be careful about, the few shot examples start influencing the completion with the content of the examples themselves. Like if my few shot examples happen to include something else about bakers, for example, then that might reappear here, kind of echoed, and that's probably not what you want. So let's think step by step was a much cleaner way of getting the behavior that they wanted. Oh, hi. Real quick question on time. When you want me to wrap this up for Q&A?
Keep going. I'll let you know.
Okay, like I can go for a while. All right. Next technique is document mimicry. And so we'll do a little experiment among us right now. Forgive my terrible artwork, but if you found this little yellow scrap of paper on the ground, what do you think the rest of this document is? It says, my cable is out. I'm going to miss the Super Bowl. And so if I found that, I think it's someone's message to a friend. It's like, sob story. Oh no, I'm going to be the butt of all the jokes. They're all going to come over and blah, blah, blah. It's going to be something like that. But if you were to find the completed document and it looked like this, then you learn a lot more about what the completion might be. We learned, for example, that this isn't just a scrap of paper with a story on it. This is a transcript between a IT support assistant and a customer. We see that the award assistant, this support assistant, is an award-winning assistant, so that's going to kind of condition what you think the answers might be. It's not like a school kid or something. It's something more powerful, or we hope. And finally, there is a pattern that we're all familiar with, and so are the models. It uses Markdown, which is a good way to communicate to humans and equivalently to models about how this document is structured and what to expect next. And so when you build up this structure and give the model something reminiscent of the documents it's been trained on, then it actually it plays the part quite well. In this case, it would start a support assistant response that is probably a good start to that answer there. So that's document mimicry. And one final high-level idea, several ideas. LLMs are not special in some respects. LLMs, when you're prompt crafting, think of them as dumb mechanical humans. All right? LLMs understand things better when you use familiar language and constructs. This is exactly the point of the last slide. Use Markdown. Use document types that are found readily on the internet rather than making stuff up on your own. And then you won't have to explain what the documents are. It'll just know them from examples. LLMs, much like my son, much like myself, get distracted. Don't stretch their attention if you don't have to. It's tempting a lot of times to create these elaborate prompts that include all the information you might need at some point. But a lot of times this gets confusing and distracts the LLM. Large language models are not psychic. If the information does not exist in training or the prompt itself, then they're not going to know about it. So this includes recent news. This includes documentation that's behind corporate or privacy walls. This includes API responses, recent, up-to-date flight information. Obviously, a model's not going to know stuff like that. And finally, most practically, most importantly, if you as a human look at the prompt and you can't make sense of it, then a large language model is hopeless. And I've seen so many times where people have been like, oh, I just think it needs this information. And like, I read it and it's like, this is garbage. I see what you're getting at, but the model's not going to, because it hasn't been working on this project. All right. So all of that is kind of the basic completion engine prompt engineering for one prompt. But our applications are not made of a prompt. They're made of the appropriate series of prompts. It's actually an application that is building a loop of prompts. And the way I'd like you guys to think about this application is as sort of a transformation layer between the user's problem space and the large language model space, which is just documents and text. The user conveys a problem, and however method you choose to do it in your application, the application transforms it into a textual prompt. The LLM has a completion that comes back in text. You glean from that, transform that back into something that you can interface with the user and go around and around. This is chat. This is everything fits in this basic model right here. The hard part, and the part where we spend most of our time, is in this top part. How do you craft the perfect prompt? So let's go over that. The way that I've laid it out in the book, and the way kind of my co-author and I learned about this through our work with Copilot, is you've got to collect all the potentially relevant context that might be helpful. Now, a lot of that context doesn't really belong there. It's not going to fit, or if it does fit, it's just not as useful. So rank the context as far as what is going to be the most important. Trim the context to make sure you cut off the pieces that are too large, cut off the pieces that don't make as much sense, and you assemble the prompt together into whatever boilerplate that makes sense. For Copilot code completion specifically, looks kind of like this. When we collect the context, the most important context, obviously, is the current document, whatever you're typing. Next up, open tabs is important, whatever your other files you've got open. The other symbols that you're getting ready to use and you're using, the information about those is important. And the file path, that's actually not included in the current document, but it's a piece of metadata that's pretty useful. When we rank the content, we've found this ordering. File path, probably technically current document is obviously the most important, but file path is so short and conveys such an important piece of information that we decided always keep it. Current document, keep as much as you can, right around the cursor. Open documents or open tabs, if you can fit them, they often contain relevant information. Symbols, this is the part that I worked on. It's a really good idea, but unfortunately, we never proved that the symbols was more useful than what was already available in the open tabs. There's some overlap there, so open tabs is easier to get access to. So there's our ranking. Trimming context. If we can't fit the open tabs, we drop them. If we can't fit text in the current document, then we truncate it until we can get as much as we can. These days, it's not as much of a problem for the smaller models that we started with Copilot, and even really for today, for the sake of latency, you still don't want the document to be, to take up the full context. It still needs to be 4,000 tokens, something like that. Assembling the prompt, this is what it looks. This is under the hood at GitHub. Whatever you're typing is not what actually goes to the model. Instead, we have something that starts with the file path. After that, we include snippets from the open tabs. We don't include all of the open tabs. This is where we're actually trimming it down. And notice we are using a pattern the model has seen before. We escape it with comments that are relevant to this language. If this had been Python, those would be pound signs. And we add information about where the snippets are from to give just a little bit more context. We include the current document to the point that we can, up into the cursor, and then we even include the information after the cursor for kind of the fill in the middle type technique. Okay, so about 3 months into writing the book, chat kind of exploded. So before that, Copilot was just code completion, and now all of a sudden, ChatGPT became the fastest rising consumer application ever, apparently, in the history of the world. So chat was obviously going to be an important thing. Let's talk about how that has changed the equation. Hopefully, you remember this from 5 minutes ago, this discussion between an IT support rep and a customer. Well, chat, this is basically the kind of document that people were thinking about when they built chat. But instead of having these markdown affordances to tell me and you and the model that has read a lot of markdown, how this is organized, they fine-tuned the model on this thing called ChatML, which basically has all the same pieces. Instead of this title, IT support assistant, there's a system message, and instead of saying, this is a transcript between these two people, it says, no, you are the award-winning IT support rep. But the model's been trained to understand that and modify its behavior. Instead of a customer tag, we have the user, and instead of the support assistant, we have forever and always this entity called the assistant. But the models have been trained to understand this format just as well as the markdown that we were using ad hoc before, even better. Now, you never see this because at the API layer, they cover this up, which is kind of got some neat qualities to it. Effectively, you always specify things in JSON, just like you see there. Same content, just different way of presenting it. The benefit of these chat systems is it becomes really easy for users to build assistants. And assistants is it's also really easy for our customers to grok assistants. We're used to typing in Slack and having these back and forth conversations. It's a conversational interface. It's what we've been doing for 50,000 years. System messages make controlling behavior a lot easier. Before, when I just created a title at the top, that would do pretty good. But these models have been fine-tuned to pay special attention to the system messages. The assistants always respond with a complete thought and stop, whereas the completion models, they might just keep talking forever if you don't have a good stopping point for them. And that used to be something we'd have to think about pretty deeply. Safety is baked in. The assistants will almost never respond with insults or instructions to make bombs. Assistants will almost never hallucinate false information. And that's really interesting how they've trained that out of them to the extent that they have. And prompt injection, because you can't actually specify chat ML, is almost impossible. So some pretty neat benefits to chat. But that's not where they stopped. Fast forward about 7 months, I think. Well, I've got the date written there. You can figure out later when you look at the slides. And they introduced tools. And probably you guys have all used the tools. You specify functions. The functions have names and descriptions. The functions have arguments, and the arguments all have descriptions. This all goes in internally behind the API. This gets stuffed into the system message in a way that the model can read it and kind of grok what's going on. Ask about that one later too. And then once we have that, yet again, the API looks very similar, but along with this user role where users can specify their questions, what is the weather like in Miami? The model now is able to complete with not just content from the assistant, but also functional information. The assistant doesn't guess anymore. The assistant says, well, let's actually use a tool that you provided me and get that. It's the job of us as LLM application engineers to actually go and get the actual information. We craft it into a response that, again, the model has been trained on to understand. And then the model gets a chance to say, call another tool potentially, or say the actual response. So tools have been a really big game changer. Before tools, the models could basically act as your personal counselor and talk to you and tell they can tutor you about history, but now they can reach out to the real world. They can read information in real time. They can write information, make changes in the world, buy tickets, transmit your bank account to someone else's bank account. They can do all sorts of crazy, wonderful, dangerous things. The model can choose to answer in text or run a tool now. The tools at this point, they started in series, but now they can also be run simultaneously in parallel. And you can have a full conversation where the back and forth is a conversation, if you need it to be, or the assistant choosing to run tools and get more information. So tools are great, but it does complicate this picture a bit. Earlier, we had this nice ellipsoid diagram on the screen. It starts looking like this at this point, which I guess is kind of like a cardioid, right? The little heart. The user now transmits a message to this prompt engineering chunk that is our jobs. At that point, we incorporate everything we can to, just like we were talking about earlier, incorporate the right stuff. We send off the prompt to the large language model. If the prompt chooses to come back with a tool usage, it's our responsibility to get the actual information, feed this back into the output, and we can go around the tool up as many times as we want. But eventually, the large language model will decide it has the information it needs in response to the user. So let's see, time left. Let's blow past this one. Basically, I was going to show you how information gets transmitted through these loops. Maybe the important thing to look at is if you ask the assistant to change the temperature and you say, put it back. A really cool thing about this step right here is we not only have access to what the user currently said, actually put it back, but necessarily we have to incorporate all the information that we have learned across the scope of this conversation, build the prompt, and it actually acts just like you would hope that it would act. So I showed you how we created the prompt for Copilot completions. Let's talk about how that is working now since we have chat. We still have to collect the context, but it's not just the code you're working on right now. It could be potentially other things. We call, I like the name artifacts. I think I'm going to start using it from now on, but at GitHub, we call these things references. What files is the user concerned about? What snippets are highlighted on the screen? What issues may they have mentioned or may they be looking at right now? All these little pieces of information can be fed into the context for the model to reason about. And then naturally, obviously, it is a conversation, and the model has to have a bit of long-term memory to have the context, not just of what you have immediately said, but the arc of the conversation. How did we get to this point? We also have a form of rank, trim, assemble with chat. There are certain things that absolutely must fit. We've deemed it dangerous to exclude the system message. Practically speaking, I think the models are pretty tame at this point, but just to make sure we have the system message, it does include important information like, hey, by the way, you're not just any assistant, you are a GitHub assistant. So that's really going to control the behavior. Must fit. The function definitions. If we're going to use a function, then obviously that has to be in there. Otherwise, we're sunk. The user's most recent message absolutely has to be the one that can fit. And if possible, you need to fit all the functions, function calls and evaluations to now, all the references that have been attached to each message, and going back in time as much of the history as you can tolerate fitting. That's going to be useful. At some point, you need to cut it off, either because it's literally too long, which is less of a problem these days, or because it's so long that you don't want to tolerate the latency problems that crop up. And if you do hit one of these walls, if we don't want to stuff more information, then maybe it's time to actually pull back some of the functionality. If you know that you're no longer going to call in more messages, then just pull the definitions of the messages out, and then you can save a little bit of space for that. Well, look there, it snuck up on me. This is our last slide. This is the time for questions. And I don't know. I think that's probably a reasonable place to stop. What do you guys think?
This is great. I got like 2 questions. So I'll start first, and then we'll open up the floor to everybody.
Okay.
Okay, so my first question is, do you think the chat paradigm is better than autocomplete or code complete in most cases?
Now, do you mean for specifically working with code, or do you mean for building an application for whatever user? Like, am I the user in this the customer on this question, or the implementer in this question?
Oh, that's a good one, because I'm thinking like Devin AI versus like GitHub Copilot chat. I guess both cases.
Yeah. Let's do all the above. We got time. When you're building an application, a completion model and a chat model both have great use cases. The publicly available frontier models have very largely swung towards chat APIs, to the extent that basically they're deprecating the completion models. And we're to say this, being in this career like 4 years now, for us old timers, we feel like we're losing out a little bit. The completion models actually provided you some neat opportunities that you don't have with chat. For one thing, it just completes a document instead of being couched inside this transcript, a document inside of a transcript. You could do things, I had a slide that I pulled out, things that you used to do. One is called inception, where basically you start the answer on behalf of the model. And like, whereas usually it'd say, okay, assistant, tell me what you want. With the completion models, you could say, okay, assistant, here's the first string that the assistant says. You like feed them what they're going to say, and then you complete halfway through an assistant message. And that gives you a lot of opportunity to really shape, how they think. You can, if you ask the assistant, how do you feel about this? But you can control the first few things that it says. You can make it very supportive and then have conversation about why it's supportive, because it'll just start generating text. Like that's really cool. Okay, but now let's re-ask the question the other way with that I think you'd originally intended it. I'm a customer to a lot of things to help me develop code. Copilot is one of them. Copilot completions, Copilot chat, and Codium, Cursor, what's it? Continuity, is that the other one? There's several in the space right now. It's getting really tight. I don't think that completion versus chat is a thing. I think both of these paradigms are very useful for certain aspects of the development process. If I am in code, then it's super cool to be typing, pause to think, and figure out that this weird creature that we've cultivated can think faster than me and is right, or it's close, even if it's just close to right. That's really cool. So I want that experience if I'm, in code, and that prevents me from having to walk away to Stack Overflow, which I haven't done in a while, or someplace else. Now, the walking away bit is like, no, this is too hard. We're not getting anywhere in line. So going out to chat, and this is the reason I don't go to Stack Overflow anymore, sorry, is because you can ask these models for your own personal customized tutorial specifically about the code that you got on the screen right now. And the code is also, you don't have to like copy and paste this into Stack Overflow, translate it to something that people can actually see and understand. You don't have to do any of that. So you get what would take 2 days to get an answer back, goes down to like 30 seconds. So I think both of those are going to be useful. I think that we are going to see a transition as time keeps moving forward, though. We will depend less and less and less upon typing the code ourselves and more upon chatting with this entity and saying, here's the code that I want, make something that does this. And like one way I personally visualize this, I really like Anthropic's artifacts that you pop up on the side. Got to write a blog post. They're not quite there the way I want them yet, but it's really cool to be having a conversation about something that stays statically on the screen. Stateful objects of discourse is what I call them. We're both talking about this thing. It's not just one conversation, and the thing I've talked about is moved off the top somewhere. So eventually, we're going to be building more and more stuff like that. And maybe at some point in the future, we'll even have it where you just describe what you want. No one programs in assembly anymore. We've let go of absolute control, and maybe this is just the next layer of absolute control we let go of. Like, give me something that does what I want, and we trust that it works. Already the case with Python. Anyway, so does that address every possible incarnation of your question?
Yeah, I answered both of my questions. So something just came to my mind. V0 chat just came out yesterday, and they have the exact layout as Anthropic's Claude artifact. So you chat on one side, you generate like a bunch of like front-end components on the right side, and it's like a one-to-one to like Anthropic's. And I think
which model is that? Because I haven't heard about this yet.
Yeah, so Vercel has this platform called V0. So it has like all the information about like these, cool kids on the block, front-end components libraries like ShatCN and all that stuff, and Next components. So people use that to generate like different layouts and cards and drop downs and stuff. So it used to be that you type in a chat box and you get like three, almost like mid-journey kind of like, here are three options you can choose from, and then you keep chatting with it. But now it's like Claude. So you talk on one side, and now it's write stuff on the other side. And Vercel has like streaming components. So it's like boom, 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 boom. Like you see everything happens in real time. And I think eventually what they'll do is they'll let you edit that code in real time.
That's what I want. That's I think everyone's going to start copying that. So far, everyone has copied everything that OpenAI has built, but I think Anthropic has finally beat them to the chase on that particular idea. I really like it.
Awesome. I'm gonna start calling everything artifacts too. Okay, so floor is open for everybody. If you have any questions for John, just unmute yourself and hop in.
I have no question. Just really enjoyed the session. So thank you, John. And hi.
Hi. Oh, hi. I enjoy giving that talk. It's a fun one.
I have a question. You mentioned cutting the context to have better result. What about all the, I guess, what is use of all these large contexts in your view then for the LLM prompting? Because the context is getting larger and larger.
It's super useful. If I have a question that is relevant to an entire book, then like, wow, cool, I can actually reasonably paste an entire book in some cases into the prompt and ask a question about it. So large contexts are going to be important, but they're not a cure-all for everything. They come with some problems. One problem is latency, because you have to process every one of those tokens on the way in. Now, if you have caching, one thing that Anthropic debuted recently, which is great, then what if you know that you have the same prefix for most of your queries, then you actually can cache it once and not have to recalculate every time. It's really cool. But if you don't have that option, then you still have to eat all that time. Your customers have to eat that time. The other thing is that you still can't just say, well, maybe this will be useful, I'm going to toss it in just in case. You have to be a little bit more thoughtful about the content that you put inside the context, because in ways that we haven't really got our heads around yet, the models can be very sensitive to distraction. Like, sometimes it's amazing. You put an entire book and you in there, and you put in like one sentence and say, find, what color is the flag? Because you just put that one sentence in and it knows it. But other times you have a fairly short prompt and you say, pay attention to this, do this thing, and it's like it ignores the text that you just wrote. And so you have like kind of this begging. So long context could still be problematic if you're just putting whatever into it. Does that make sense?
Yeah, I'm kind of curious. I haven't tried large context lately, but I tried it like maybe half a year ago, and it that did seem the longer context I put in, the less consistent useful the result was for my specific use case. So I'm kind of curious. Yeah, like what is a good use case for large context? Yeah, thank you for that answer. If I may, can I follow up with another question?
Sure.
Okay. So the powerful thing about this Gen AI is it's non-deterministic, but to use it in like the typical kind of software where we expect things, the workflow, we expect things to be consistent. So I'm kind of curious, what are your thoughts on that in general, just how to use LLM in these more deterministic, typical standard workflows that you see in software development?
I feel like there's kind of two paradigms for implementing applications right now. And now, even as I say that, I'm not sure I quite agree with that. There's going to be several, but there's two paradigms in my mind right now for writing applications. One is a chat assistant type application, which is a loop that takes a user message and then figures out how to run tools, gets the answer back to the user, and it's that type of loop. These things are very useful because you have your user tightly integrated, and every time the model and the models aren't trained to completely solve the problem, they'll just make one or two function calls and come back to you. And the user, the way you get around the non-determinism is you just keep the user tightly in the loop, and the user says, okay, I see what you got there. 90% of that is helpful and 10% of it is crazy. So we're gonna like, adjust the conversation just like, humans would do with one another. The other paradigm that I think can be useful here is where you're working in terms of like workflows. Basically, if you have a complicated task that a user is not going to be able to be involved with for a corrective influence, you say, okay, here's a complicated task. Let's divide it up into the reasonably smallest tasks that we can do dependably well. And if we can't do a particular task dependably well, then we actually augment that with like some rationale after the fact. Like, did we end up in a happy state or a bad state? And what you do is you just process your work items through a workflow. You get hopefully a lot of ideals I'm waving around here. In an ideal world, each one of these tasks is associated with its own like miniature benchmark. Like, this is what I expect to see out of this. You can optimize, fine tune. I'm not gonna say that word. I don't mean literally fine tune. You can optimize each one of these tasks independently, and then hopefully, and there's a little bit of hope involved, tasks that work in isolation, once you put them back together, will also work in the full workflow. Absolutely not foolproof. I'm building such a workflow right now where it's like, each one of these things will get it right 90% of the time, but we've got 10 such things, so that's a lot of places for errors to group in. And my answer to that is we don't exactly know yet. We're doing a lot of grappling as a community to figure out what's exactly the best way to increase the percentage of success as much as we can and recover gracefully when we fall through the cracks.
Thank you very much. That's a really wonderful answer.
Thank you. Any other questions? You talk about skeletons in my closet.
Yeah, about that. I feel like we all waited until the last part of this presentation to hear.
Hey. Let's see. For the sake of eye candy, I'm going to share my screen again. we'll do that cool zoom effect. Meet my dad. And that dapper looking fellow right there. My dad's a forensic anthropologist. His specialty is in bone fracture research, and basically, if anyone finds bones laying out in a field somewhere, they'll call him. And if it's sometimes he can just look at a picture and say, "Oh, that's a deer. Leave me alone." But he's picked up a lot of really interesting forensic cases and a few really interesting historical cases as well. Probably the most generally recognized one is Kennewick Man, who's one of the earliest and almost totally complete human specimens found in North America. It was found in Seattle, or near Seattle, and it was interesting because it wasn't stereotypically Native American in appearance. It looked like a mix. It looked like something that we wouldn't quite expect for that area in that time period. So, anyways, we literally did have skeletons in the closet back in the day. He tried not to take his work home very much, which is very fortunate. But I do technology stuff, and he has all the stories.
So you must know quite a bit about like skeletons, I would imagine.
Not as much as I should. I know a little bit here and there, but I think we have 206 bones. We have 206 bones. There we go.
That's not a piece of information that I learned today. So thank you so much for that. I think that's it. That's the webinar. So thank you for hopping on, John. This has been an amazing presentation. We'll drop the presentation link, the file in the description of the video. And yeah, that's it.
Thank you guys so much. It was a pleasure.